Okay, hi and welcome to video notes on finding exponential models. And what that means for us is that we're going to be given a couple different situations that we're going to be asked to write the model for. One, we do need to know that it's exponential. So that's the first condition. But once we know that, based on the fact that they give us either a couple of points and not a lot of information, we can write a model. Or two, if they give us a table of values, with multiple points in it, obviously, as many as they want to give us, we can also write the model for this. Now, there's two ways that we're going to do this. One, if they give us A, and that's the easiest way. If we can find A, it's a little bit easier. If they don't give us A, then it takes a little bit more figuring. It's not difficult by any means, but we should be able to do it. And we've got two different kind of processes that we can do that with. So here are the directions. I'm not going to go through those right now. I'm just actually going to put them right into an example and have you see it as we go through. So what I've done then is I've gone down here to the first example, actually all the examples, and you notice I said this one's with A, this one's without A, and you'll notice the last one, saved it for the best one for last, is without A, and it's not consecutive, and we'll do that one as well. So on the first example here, we know that this is A by this 0. That 0 tells us that that is on our graph, that's kind of our vertex, right? So if our exponential function comes up, we know that the A value is always where it crosses the y-axis. So you can call it our y-intercept if you want. You can call it our vertex. We've talked about it in that form. But anyway, what we're looking for is that 0. And as soon as you do, you know that A is 2. So that's good. We've got a piece of information. So let's label that. A is 2. We'll label it again. All right, we're also looking to find B. We need to find A and B to be able to write the model. Because don't forget, this is what the model looks like. Y equals A times B raised to the x power. So we've got A. We've got to find B. But if we look at this, we've got Y is one unknown, A is an unknown, B is an unknown, and X is an unknown. So we really have too many unknowns to solve for if we're really looking to find B right now. Because we've got A, we just need B. But we do have two other pieces of information, X and Y, that we can find from a point. And we can use that point to go ahead and calculate this for us. So that's what we're going to do. And that's what it says right here. So let's plug in the information we got into our base model and see if we can go ahead and solve for this. So we're just going to take Y, which is 162. We're going to set that equal to our A value, which is 2. We're going to multiply that by our B, which we don't know, so we'll leave as a B. And our X is going to be 4. Okay, so now we're set up. We only have one unknown. So we're going to go ahead and solve this. Again, standard solving procedures or reverse order of operations. In this case, we're going to deal with the multiplication before we get to the exponents. That's the way that says. So we're going to go ahead and divide by 2. So that obviously equals 81, which is equal to B to the 4th. Now, we got to get rid of an exponent of 4. We haven't done a lot of this, but you should be somewhat familiar. We know that taking a square root is the inverse of having some value squared. We know that those are inverses of each other, taking a square root. They cancel each other out. But what about a 4th power? Well, we're going to take what we call the 4th root. And so if this is the first time you've seen it, that's okay. What we'll do is we'll take the 4th root. That just means find a number times itself 4 times. It makes 81. You can put that in your calculator. And what you'll find out is that it's 3. Okay, so we find out that our B value is going to be 3. Guess what? We're basically done with this problem. All we have to do then is write in the two pieces of information that we just found, which is A is 2 and B is 3. So here's our new model for this situation based off of those 2 points. Y equals 2 times 3 to the x. Remember, we want Y and X, or X and Y, we want them to be open because one's an input, one's an output. And that's what we want a function to look like. Have a spot to go, something for it to go in, and have something for it to go out. So there's our model for a set of points. If we have A, not so difficult. You have to take the root based off whatever. So this is a 3, you take a cube root. Just put it in your calculator. All right, well, let's move down here where we don't have A. Okay, if we don't have A, we approach it a little bit different. There's 2 ways we can approach it. We'll take the common ratio method first. So what we're going to look for is finding the common ratio. And we know how to do that from our first days of notes. And we said that we take the 2 consecutive Y values, again, make sure they're consecutive, 1 to 2, 2 to 3, 3 to 4, so these are consecutive, and we divide them. Y2, I'll write it over here, Y2 divided by Y1, and we keep that pattern all the way down the list. So 1 divided by 2, 1/2. 0.5 divided by 1, or that's another way to write 1/2. And again, you can kind of see the pattern happening. So this would be 0.25, and you can put this in your calculator if you need to. Divided by 0.5, that'll also equal 1/2. And you'll find that it's 1/2 all the way down. That gives us a great piece of information, which is B. So now we've got B, and let's start listing our information that we need. We don't have A. We said that wasn't our part that we got, but this time we've got B. So I'm going to go ahead and put B as 1/2. Okay, so again, thinking that we're going to put this back into our regular model, so y equals a times b to the x. We're going to start plugging stuff in. Let's go back and solve for a now. We have lots of points. These are all x's. These are all y's, right? So we have lots of points to choose from to put these back in to solve for y. So let's plug it in. Let's pick a nice and easy y, or one of these first two, 1 and 2. They're both some combination of 1 or 2. Both of those are pretty easy to use. So let's plug in, we'll use this point here. Y is 1. Our a value we don't know, so we're going to leave that unknown. Our b value is going to be 1/2. And we said our x value is going to be 2. Okay, so if we look at that, we should be able to clean this up a bit. Can't do anything with a. We can't do anything with 1 yet, but we can square 1/2. Well, 1/2 squared is 1/4, right? 1 squared is 1, 2 squared is 4. Make sure that you get both of these squared. I know nothing happens with the 1, but that's what we still have to show it. So now we've got these multiplied together. How do I get rid of a fraction that's multiplied by? Well, we multiply by its reciprocal. So I'm going to go ahead and multiply by 4. These are going to reduce away to 1, and then I get 4 times 1, or a equals 4. Guess what? We're ready to write our model. So y equals 4 times 1/2, which is our b value over here, and then raised to the x power. So there's our model for that situation. Now, you want me to show you the easier way to do it? Let me change my color for you. We'll pick a nice green. We can use the pattern in the table as long as it's consecutive again. And this one is. We can use this pattern to help us find or work backwards. Because we don't have A. A starts at 0. We have 1, though. We're right close to it if we just knew what this value was going to be. I mean, we solved for it. It's 4. But watch. If I go down this list, each one I'm doing is being multiplied by 1/2. So if I go this way, I'm multiplying by 1/2 or dividing by 2, whatever way that you want to look at it. So if I go the opposite way in the list, if I go back the list, I have to do the inverse of what's happening, which would be multiply by 2. Then look at it and check it to see if it works. If I take 0.5 and I multiply it by 2, do I get 1? Yeah. If I take 1 and I multiply it by 2, or yep, if I take 1 and multiply it by 2, do I get 2? Yeah. So if I take 2 and I multiply it by 2, I get 4. So you can use the pattern, if it's consecutive, to work backwards to a 0, if you're close to it. Or even if you're not close to it, you can work back far enough to find A. That's fine to do. That's perfectly fine to do, because there is a pattern as long as you use the pattern correctly. Again, dividing to go to the right by 2 and multiplying to go to the left, you can go ahead and work your way around and find any new value you want. That would be the easiest way to do this, is to use the pattern to find A, find the common ratio, check, you're done. No solving required. So let's go down here if they're not consecutive. All right, so with non-consecutive numbers, we could try to find the common ratio, but we will have to adjust it, because this should go from 1 to 2 and then from 2 to 3. So there's a multiplication that we would miss if we did this common ratio this way. We'll do the common ratio this way. So we'll take 162 and divide it by 18. We're going to get the common ratio, but it's inflated. It's a multiplication larger than it should be, because there should be another multiplication in there. So if we do this pattern all the way down, and you can check with your calculator, but I've already done that, I know that all of these are going to end up being 9. So, and you can do that all the way down. These are going to all result in 9. The problem is, it's not really B yet. That's not B. We have to account for this gap. Let me change my color. So to account for this gap, these gaps in our sequence here, these gaps in our sequence, right, that they're not consecutive. What we need to do, let me scroll this up, is we need to, this is for the gap, I'll right here, take the root of however big the gap is. So whatever the number of the gap, in this case, notice our gap is 2, right? Our gap seems to be 2. What we need to do is take that number and take the root of whatever that gap is. So our gap is 2. Let's say it was, from 5 to 9. Well, that's a gap of 4. So then we would use 4 for this. But since it's 2 for our example, we're going to take this number and we're going to take the root of that gap of that number. So this is what it would look like. Are you ready? I'm going to take the square root of 9, which is 3. There's your common ratio. That accounts for that gap of the non-consecutive part of our sequence. So if it was 10, we would have taken the 10th root of. So our common ratio is 3, which tells us that that's B. So we'll start listing out our information. So A is equal to, we don't know yet. B is equal to 3. We do have that information. And if we know it's working by 3, and we know that these are multiplications of 3, so 18 times 3, let's check that real quick with our calculator. So not one that I do in my head very often. I probably could figure it out though. Should be 54. That would be the part 2 if it was there. Then we could move up to 162. So 52 or 54 times 3 should be, and we'll check it with our calculator again, just to make sure, 54 times 3, because that's our sequence here, is 162. So we can use, the easiest way is use this idea of this pattern that works between here, right? Our common ratio multiplying up. If it's multiplying to the right, it means it's going to divide to go to the left. So if we take 18 and divide it by 3, we should get us down to 0, which would be 6. So A is 6. And we could write our function pretty quickly, or our model for our function. Okay. Otherwise, we would go back up here, and just like we did before, we'd find our pieces of information. We would say we didn't know A, right? And we would plug in everything we knew, pick a point, plug in our X and our Y. Oops, let's make it go down here. So we would say, this is what we would do. I'm just going to show you the alternate way to do it. This way is the easiest way if you can do it. Our Y would be 18. A would be, we wouldn't know, right? So it would stay A. And then we would multiply by 3 raised to 1, the first power. And you can see that that's going to quickly work out to be A is 6 as well. So we've done that a couple of different methods. If you get this idea of the common ratio, it works out really well. If you can work the pattern one way and work it back the other to find A, that's actually the best, right? And we've seen it done with A. That's actually our easiest method to work with. And you can even apply this gap adjustment up here now, right? Our gap would have been from 0 to 4. We would have taken the 4th root of that number we started with originally, which I didn't write down. So there's your notes. That should be your video notes for everything else. When you get back from break, happy Christmas break, by the way, happy holiday break, we're going to do an activity based off of this. You're going to do this in class. You'll walk in and just duplicate these notes. So you can rewatch the video if you need to, and you have your notes here to help you through it. And that'll be a nice, easy day back from break, just kind of working through some problems. All right, thanks for watching, and we'll see you when you get back.